video is about equivalent decimals. Equivalent decimals are decimals that name the same number or decimals that have the same amount. Just two different ways to say the same thing. Here's what's important. Inserting zeros or remaining zeros behind the last non-zero digit in the decimal does not change the number. Well, that's all very fancy and can be confusing. So let's look at what this says. Inserting a zero or remaining zeros. So here's my remaining zero here in this example. This is the last non-zero digit is 3. My last non-zero digit is 3 here. So if I were to put another 0 here, what this is telling me is it doesn't change the value of the decimal. Neither does this. If your answer has the 0 at the end, I could take it away and it doesn't change the value of the decimal. They're still equivalent. So if I put a 0, inserting a 0, or any remaining zeros that are behind the last non-zero digit, any number that's not a 0, like my 3, if I inserted a 0 here, it does not change the number. I could put as many zeros here as I wanted to, and it's not going to change the value of that decimal. So here's another way to look. Here's a way to look at equivalent decimals. In this picture, in this example, I have 2/10. I have 2 of these, and this shows 2/10, and my decimal is 0.2. I say it is 2/10, and it's telling me that it's 2 out of the 10. So here, 2 out of the 10 are orange. 2/10 is orange. Over here in this example, I have 20 of these little ones. So I have 20 out of 100 because I have 100 squares. Over here I had 10 columns. I was looking at the columns. Over here I'm looking at the individual squares like this, and I have 20 of them. So here I have 0.20 telling me it's 20 hundredths because there are 100 little squares and 20 of those are orange. 20 out of the 100 are orange. So if I look at these, they look just alike. So it's telling me that these are equivalent. These are equivalent. This is equivalent. And actually this is equivalent also. So what this tells me is that 0.2, which is read as 2/10, and 0.20, 20 hundredths, are equivalent decimals. 2/10 is equal to 20 hundredths. So all of these are equivalent. I can also use a place value chart to help me look at equivalent decimals. Here I have, in my ones place, I have zeros, so I don't have any whole numbers. My decimals get their own place. In my tenths place, I have 3s. And in my hundredths place, here I don't have anything, but in this column I have a 0. So using my place value chart, I'm going to write out the decimals that I have. So number 1, going across, I have 0.3, and that is read as 3/10. Here I have 0.3, and then I have that 0 in the hundredths place. But what I just learned is it doesn't matter how many zeros I have after my last non-zero digit, it doesn't change the value of my decimal. So 3/10 is equivalent to 30 hundredths. A lot of times we see decimals used in money. So let's look at equivalent decimals as money. I have no dollars, 30 cents equals 3/10. So I'm looking at this as columns. 3 of my columns are orange to represent my 3/10. And it's 0.3 of a dollar. It's 3/10 of a dollar. Well, how much is 3/10 of a dollar? 3/10 of a dollar, if I'm going to divide my dollar into 10 equal pieces, it takes 10 dimes to make a dollar. So I have 3 of them, 10, 20, 30. So it's 30 cents. Each column is equal to 1/10 or 1/10 of a dollar. 1/10 of a dollar is a dime. So there's my 30 cents. Well, what if I come over here and I have hundreds? It takes 100 what to make a dollar? 100 pennies. So each of these little cubes now represents a penny, because I'm looking at each little box up here, and I have 30 of those little boxes colored orange. So I have 30 hundredths, because there's 10 here, 10 here, 10 here. So that's 30 of the 100. Well, what's 30 pennies is equal to 30 hundredths of a dollar is 30 cents. So you can see that it's the same amount. Each square here is equal to 0.01 or 1/100th of a dollar. It takes 100 pennies to make a dollar, or 1/100th of a dollar, which is the pennies. So if I have 30 hundredths, it's the same as 3/10. So 3/10 of a dollar is equal to 30 hundredths of a dollar, and both of those are the value of 30 cents. So let's look at these decimals and see if they are equivalent. Remember, any zeros after the last non-zero digit, they don't change the value of the decimal at all. So if I have 0.4, that's read as 4/10, and over here I have 40 hundredths. Well, if it helps, I can say, well, there's my last non-zero digit, so any of these zeros after that don't matter. So maybe it's easier to see now that 4/10 is the same as. So are these equivalent? Yes, these are. How about this? 1/10 and 1/100th. Are these equivalent? No. Don't let the zeros trick you. Don't let my pen trick you. Don't let the zeros trick you. This zero is in front of the number, not behind it. How about 0.20 and 0.2? Here I have 20 hundredths, and here I have 2/10. Are these the same? Yes, because my zeros come after my non-zero digits. I could cross that out if that helps me, and I can see very easily that yes, these two decimals are equivalent. How about 0.18 and 0.81? Well, if you're going really fast and you're not paying attention, you might get tricked here, but don't let it trick you. The numbers are the same, but number order matters. This is 18 hundredths. This is 81 hundredths. Are these equivalent? No. How about this? Now I've pulled a whole number in. I have 2 and 13 hundredths. And here I have 2 and 3 hundredths. My zero is in front of my non-zero digit. Here I don't have any zeros, so I look to see 13 hundredths, 3 hundredths. Are these equivalent? No.